Hello everyone, welcome to my channel One Concept W. This is one of the DC machine question. Let's solve this question. Here it is given, it is a DC shunt motor with a terminal voltage of 250 volts and 4 pole machine P equal to 4. And they given the armature winding has number of conductors Z equal to 500. Armature circuit has a resistance of 0.25 ohm, Ra equal to 0.25 ohm. And field winding resistance Rf equal to 125 ohm. Rf equal to 125 ohm. And flux per pole they given 0.02 Weber, and they given the armature reaction is neglected and the motor draws in current of 14 amps from mains. Means you start taking in current of 14 amps. They are asking to find speed and internal torque developed, and they are asking to find shaft power and shaft torque and efficiency if rotational loss is equal to 300 volts. Let's summarize the data here. Given it is a DC shunt motor and armature connectors of 500 and armature resistance of 0.25 ohm and field winding resistance of 125 ohm. Flux per pole equal to 0.02 Weber, and they given the load current means the drawing current IL equal to 14 amps. Let's find the field current. IF equal to VT by RF. VT is in terminal voltage of 250 volts and RF field winding resistance of 125 ohm. The field current is 2 amps. The armature current IA equal to IL minus IF. IL means the load current drawn from the supply. It is 14 minus 2. IA equal to 12 amps. Back EMF EB equal to VT minus IARA. VT is 250 volts, IA equal to 12 amps, armature resistance of 0.25 ohms. By this calculation, the back EMF EB equal to 247 volts. We already know the back EMF EB equal to Z by A into P into pi into N by 60. Z is in number of conductors, A is in number of parallel paths, P is in number of poles, pi is in flux per pole, N is speed in RPM. N is in speed in RPM. By comparing EB equal to 247, all the data, I found a speed of 741 rpm. Means under this condition, motor is running at a speed of 741 rpm. In question number 1, they are asking to find speed. Speed we calculated here, speed of 741 rpm. They are asking to find internal torque. Internal torque. Internal torque developed equal to EB into IA by omega. Internal torque is nothing but power developed by omega. Omega in radian per second. Here we already know back EMF will be equal to 247 volts and armature current of 12 amps. By substituting the data here, we already know the speed is in RPM 741. By converting into radian per second, by substituting all the values above, I got internal torque of 38.19 Newton meter. They are asking to find shaft power. Let, let's see this question B. In question B, they are asking to find shaft power, shaft torque, and efficiency if rotational loss equal to 300 volts. Shaft power is nothing but an internal power developed minus rotational losses. Internal power is EB into IA. This is 247. Here this is 247 and IA is in 12 amps. Means 247 to 12. They already give the rotational losses is 300 watts. But the shaft power is 2664 watts. Shaft torque is nothing but an power developed by the shaft divided by omega. Omega is in radian per second. By substituting the value, I got a shaft torque of 34.33 Newton meter. They are asking to find efficiency. Efficiency is nothing but an output power by input power. We already know output power is in shaft power. Shaft power is 2664 watts. Input power. Input power is the supply, the power drawn from the supply. Here the current drawing is in 14 amps and supply voltage of 250 watts, 250 volts. Then power input equal to VT into IL. This 250 into 14 will be input power. By substituting the input power here, I got an efficiency of 76.11%.